sphere varies as a function of r. A tunnel is dug along the radius up to depth and a body is projected from the bottom of tunnel as shown in figure so that it escapes from the earth gravity if velocity of projection. So it's also again say some small idea. You somehow what happen, you should get that concept involved. I think the rest all you can manage. Tunnel is only till r/2. Okay, this the center O will take it. There's a radius r, radius of the tunnel, and the length of the tunnel is r/2. It is projected from here. The particle is projected from here so that it will escape to infinity. We'll call this is 1, 2. See, what will be that at point 2, it must have the escape velocity. But look at the density of the earth. Any changes will you make it or no, nothing that one. So we should know when density is varying, what is the potential? We know potential when it is of uniform density. Will I agree? Please get into the concept here. The density here, in fact, it's variable. So when density is varying, what is the potential at point 1? Or we should know first potential at point 2, then we can calculate potential at point 1. Am I right? Then what is the mathematics involved? The mass involved should be, it's a purely now this one. So let's assume a sphere of radius r. I'll assume a strip. Let's get into this one. Okay, this is the center of this. So first we should calculate the field inside the sphere of radius r. Then I'll come to problem. First, I think we should manage with the thing. So let the mass be a dm. So what is the mass of the strip? It's not a ring, it's a thin shell. So dm should be equal to rho into 4 pi r square dr. What is rho? Rho naught r. 4 pi rho naught r cube dr. This is the mass of the thin shell. How much of mass is enclosed? I'll draw a Gaussian surface inside this shell. How much of mass enclosed means 0 to smaller. So mass enclosed m dash equal to 4 pi rho naught. Let's repeat some mathematics. So now what is the field strength at this particular point? E. Expression for E should be equal to directly shall or apply Gauss law. 4 pi r square E equal to E into ds. I think I'm adding E into integral of ds. 4 pi g net mass enclosed by the Gaussian surface. So this should be equal to 4 pi r square 4 pi g m dash will be pi rho naught r to power of 4. So 1 pi will get eliminated, 4 will get eliminated, pi g rho naught r square. So this is the expression for the field inside the sphere, that one. So now what will happen? So what we can do is like, after getting this E, we should calculate the potential at that point. What is the potential on the surface? So we should know potential at point 2. What is the total mass enclosed? 0 to capital R. Total mass of this. So how to calculate M? 4 pi rho naught. What is the potential at point 2? Potential at point 2 is given by minus Gm by R. So minus pi G rho naught R cube. We know potential at point 2. Now we know field inside. I'll calculate potential at point 1. So what is the formula? dV equal to minus E into dr. Oh, time being, let me write it. So this will be, we know potential on the surface, V2. Potential somewhere inside at point 1, we don't know. That has to be determined. Then what is the value? Capital R. This is smaller. So this will be V1 minus V2. Angle between E bar and dr bar. E bar will be directed, dr will be radial outward, E bar will be radial inward. Angle will be 180 degrees. So this will be E dr cos 180. What is value of E? Pi G rho naught R square dr. We know potential at point 2. I'll substitute later on, that is. There's a limit is then. Okay, fine. So like this, I'll calculate the potential at point 1 using this formula. Now what is smaller? Smaller should be equal to R by 2. Later on the expression, I'll write smaller equal to R by 2. So this will be V1 substitute now. Substitute all the values. Smaller equal to R by 2, you'll get the potential at 0.1. Now, after this, what we have to do? The question is not at over, only just we are getting potential at 0.12. He's asking, it should escape to infinity. With what speed? It should be projected from the point 1, from the bottom of the this one. So what else? So now you know potential at point 2, no? So now come back this. I think I'm showing everything. Okay, first we'll calculate V1. Anybody? V1, V2 should be rho naught R cube. We'll get potential at 0.1. Solving this, we'll get potential at 0.1. After this, what we should do? If you project from point 2, what speed needed? Then what happened? For the particle to reach point 2, what speed is needed? That has to be calculated here. V2, V1, V2 are potentials and not speed. And now what is the escape velocity? So with what speed you should project from the surface of the earth so that it can escape to infinity. Calculate that one. I think now can you use the same formula, but here the mass of is you have to substitute pi rho naught R square. So no doubt escape speed should be equal to how much? G into mass by R. What is M? M you have to substitute this one, 2G. So what is value of M? M should be pi rho naught R to the power of 4 that you substitute. Now with what speed I should project from point 1? Tell me what shall I do? I'll apply conservation of energy, mechanical energy from 1 to 2. So what is the formula now will be? M, small letters, capital. Small letters are for speed. mv1 square. Potential at that particular point you should calculate. Expression for potential will be m into v1 let's say should be equal to please do follow this equation. This is something very important. Do we know value of V2E? Yes, we know V2E. Do we know value of V2? Potential at point 2? Yes, we know. Do we know potential at point 1? We know. So we'll get the speed with which I should project from the point 1. So what are these things? This is the speed of projection at point 1. Something calculations will be involved. I don't think so. You can't remember any data because rho is given, rho naught or some other value will give. Better to remember the methodology here. The last equation is very important in terms of potential and bringing, not interaction potential. Mass into potential at that point will give interaction potential. There's a necessity to find out the potential on the surface and potential inside. Okay, I'll stop the class. Any other? I'll give assignment, try to work out few. Huh?
Sir, it should be plus MV2 no, sir, in RHS.
Okay, I have to sign here. Yeah. Because V2, I'm going to substitute this sign. Yeah, signs, okay.